Cole Robertson here today. I'm going to talk to you about macromolecules and why we as humans find them cool, and not just because they're commonly found in your fridge or your freezer. Some forms of macromolecules, protein, steak, red meat. Also for people like to hunt, you have your deer meat, also another good form of protein. A macromolecule is made up of thousands of atoms. So say this ball here, and each one of these blades of grass is an atom. This would be a macromolecule. And what a macromolecule basically is a large molecule, such as a protein, like I said earlier. But a macromolecule are commonly made through polymerization of smaller subunits or monomers. Commonly, macromolecules have thousands of atoms, and occasionally, sometimes millions. But some of the most common macromolecules in biology, chemistry, or biopolymers, such as nucleic acid, which is RNA, and DNA, which is ribonucleic acid, and deoxyribonucleic is dependent on 3 biopolymers that are needed in biological life. So, what are those things? You have DNA, RNA, and proteins. Now, the NA in RNA, or the NA in DNA, is nucleic acid, which is a macromolecule. So, DNA, as we know, is the code of a human, which is different. That's what makes you different from the person next to you or the person riding beside you. Another macromolecule that we haven't talked quite as much about is the carbohydrate. A carbohydrate, as we all know, carb or fat. But what's crazy about this is it's not really important to our genotype or our phenotype. It's an important macromolecule because it plays an important role of our intake on food. So even though maybe we don't have the carbohydrate macromolecule inside of us when we were born, or it's not composing us or making us what we are, however, it is in what we eat, such as a buttermilk pancake, which is quite full of carbs, as I'm reading. So what that means is we intake carbohydrates, we intake macromolecules which feed us. So let's backtrack a little bit. DNA and RNA, which makes us who we are, has macromolecules in it. A plastic bag, which you put your carbohydrates in, or your proteins, another form of macromolecules. And then you have your macromolecule itself, which makes up all of these things. So to be able to know what a macromolecule is, understand, you kind of understand the concept of everything, because the world is made up of atoms and cells, but a macromolecule is an atom. Another good importance that we know about carbohydrates, which is, like I said, a macromolecule, is that we use that every day. We use carbohydrates as energy, such as to do everyday things, as walking to the refrigerator to get more carbohydrates, or walking to class, or walking into biology with Dr. McIntosh. All these little things that we do every day is because of macromolecules. So something else that we often don't think about as macromolecules is sitting on something like I am right now, is a fabric, handmade fabric, upholstered, which has macromolecules in it. The computer that we do all our assignments on, D2L, that is all macromolecules. It's made out of petroleum and plastics and all these different, thousands of different things in it that all have macromolecules. So the importance of macromolecules is not just that it's a macromolecule, but because a macromolecule is made up of atoms. So without the atoms, we wouldn't have macromolecules. Without macromolecules, we wouldn't have computers or stuff like that. So everything that we have is based off of one central fact, that we have atoms, which then macromolecules are thousands of atoms, and then those thousands of atoms make a macromolecule, and that macromolecule makes carbohydrates, proteins, lipids, nucleic acid, which, like I said earlier, is probably the most important part about macromolecules.